Static Code Analysis with Patrick Smacchia.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your humble host. Make sure to check out www.azuredevops.show for past episodes and show notes. And a few announcements. My latest book, .NET DevOps for Azure, is available. You can get it now at bit.ly/.NET DevOps book, and the ebook at bit.ly/.NET DevOps ebook. And also a special offer for user group or conference leaders or anyone speaking at those community events. And for those in-person events, I'd love to send 2 copies of the book for you to give away to the attendees. So to request those, you can go to bit.ly/.NET DevOps book for community. And I've signed on with A Press, and they will be the official publisher of the book. And you can, it's available now if you just go to the URLs, but we're getting it through the final stages to get on Amazon and other places, and also working on some edits for a .NET Core 3 edition at the end of the year. All right, let's get on to the show. So Patrick Smacchia is the founder and CEO of NDepend, a tool for .NET static analysis, and he's been in the software world for over 20 years and is one of the world's top tier experts in static code analysis. Patrick, I'm excited to have you on the show. How are you, sir?
I'm fine. How are you, Jeffrey? Very
good, very good. This is going to be a fantastic show and something that everyone needs to know in the DevOps world, how to put in place static code analysis and what the heck it is. And you're an expert. So how do you think of static code analysis? What is that?
So I think to speak about static analysis, we have to talk about 2 things, because there are 2 things in opposition. There is first the static analysis, and second there is the dynamic analysis. And the 2 are about code analysis, but the data are very different. The data of static analysis is the code itself, okay, and the data of dynamic analysis is the code execution. The code execution data you can get, like performance, CPU performance, memory consumption, number of objects, etc. While the static analysis is really about the code. This is interesting because the code is seen as data. Okay, the same way you can see like relational data and have some SQL queries to query. In static analysis, you can have the code as data, like the row can be replaced by the classes, for example. And this is always interesting. This is something every developer should have to keep in mind. This dichotomy is that often I read object for classes, for example, in documentation or in book, and often the author really want to say classes. Okay, and this is something I like to be very strict, because object is at runtime and classes is in the code itself. Okay, so static analysis is about code as data that you want to query. I became interested in static analysis like around 15 years ago. Okay, I was like consulting in a large companies like as many of us, and as many of us, I saw a lot of big legacy application. And at that time, I was reading a lot of books, as I still do, but maybe I use more online services right now. Well, one of the books that struck my attention was about Robert C. Martin, aka Uncle Bob. Okay, Agile Software Development Principles, Patterns, and Practice.
Right.
I take a chance to do a bit of advertising for this great book that has been actualized. And this book is very interesting because it's full of principle, but what struck me at that time is that this book considers code as data. Okay, this guy, like, for example, in the solid, if you look at the interface segregation principle, You want to know about how many members do you have in interface, because of course if you have like 10 or 20 members, maybe the interface segregation principle is violated. So I was trying like, hey, you can get some metrics, you can get some measurable data from code, and then infer from this data, you can infer some interesting things. Like, for example, if I have a too big interface, certainly I have a problem, and I am violating solid principle. So everything gets started from there. Then during my spare time, I wrote a quick open source tool named NDepend. Okay, and the name was inspired from a GDepend, which was on the Java side, and the idea was to analyze some code and some .NET code. I was really early in .NET, certainly like you, I think in 2002, and the idea was to gather some metric and some more data from the code to see what I can come up with. Maybe I can have some diagram, and maybe I can have some sort of rules. So NDepend started like that, to try to show the developers some information buried in the source code, and like doing a tool like to do some code review, some automating parts to automate some part of the code review with the tool, and everything started like that. It was just a 2-day quick project, and I am now working on it for like more than 15 years. Okay,
that's a long time.
Yeah, that's a long time, especially in the IT. And now there is a team. Now there is several flavors. There is like Visual Studio extension, like Azure DevOps extension, full-fledged inside Azure DevOps, both cloud and server, because now the server is TFS. Microsoft like to renew the technology, to rename the technology. And that's really what's really interesting is that everybody can see that the net is just getting bigger and bigger, especially with the new .NET Core stuff, and which will be very soon next year the only .NET. And so this is interesting because for everybody in the .NET sphere, like developing like toolings or having an expertise, this is really cool because .NET is just getting bigger.
So that's a big idea. I don't want to brush past it. Treating the code as data, because normally we think we're going to write code and our code is going to operate on data in SQL Server and other places. But with static code analysis, you're actually treating the source code itself as your database.
Yeah,
and
absolutely.
So if you're treating it as the database, then presumably we're going to query it for problems, right?
Yeah, absolutely. Yeah, that's why I mentioned the SQL. So first, I would like to mention something very important. That since a few years, Microsoft is providing a massive framework named Roslyn. Okay, that does tons of things. So of course, it's a compiler, but it's also a big framework dedicated to write some rules. Mm-hmm. Okay, and if you think about it, Roslyn is also a way to see code as data. Okay, Roslyn goes very, like even a tiny space in your source code will be a tiny data in your Roslyn. So basically, with what's interesting is that with Roslyn, you get every possible data you can gather from the source code is in Roslyn. Okay, and what NDepend is doing, so NDepend is developed for like 15 years, and it of course it existed before Roslyn, that became mainstream in around like 2014 or 2015, and NDepend is not based on Roslyn, as most of tooling you can see. So I can name, of course, all the Roslyn analyzer. I can name also the Sonar Source C# rules. Okay. And I can name also ReSharper. That's interesting enough is not on Roslyn based, but they have their own Roslyn that they are maintaining. Okay, and NDepend is a bit different in the way that it's importing only a subset of data, mostly related to the code structure. Okay, so for example of data that NDepend is good at knows a lot about is like all the object-oriented stuff. Okay, like the derivative, like the methods override, etc. All the dependencies, okay, the dependencies between members, classes, namespace, assemblies, etc. NDepend provides many dozens of metrics out of the box. Okay. Also, NDepend has the notion of baseline, which is very interesting because then one very particular things in the development in the software industry is that we are very interested by the delta. Okay, we have a big legacy that is working in production, and then we are doing new feature and we are fixing bugs. And at any point in time, we are very focused on the delta, on the current evolution. And to reflect that, NDepend has this notion of baseline. So, for example, you can write some query on the NDepend model, like I only want new, for example, let's say new big methods or complex methods that are not covered by test, for example. Okay, I only want the new methods since the baseline. And that's very interesting because then one major problem, maybe I didn't mention in static analysis, is that no matter which tools you are running on your code base, you're going to have, it's big enough, you're going to have hundreds or thousands of issues reported. And it's not very practical to think like, hey, I'm going to have to fix it all now. Of course, you're not gonna stop for 3 months all development to fix everything at all. So this is why this baseline feature is very important because you can only say, okay, from now the code is as it is, but what I want is that every new classes that I will add or refactor, also all the refactor I will do on some existing classes, I want to make sure to track all these new things. Okay, yeah. So this way the code quality will improve progressively with no upfront investment. Like, hey, we have like 2,000 issues. Let's fix them all and be green. Like often in our field we are using the word green field. Like we want to be. Problem is that in the real world, green field is not very practical. I mean, except if you are really starting a project from scratch, which is more the exception from the rule. So there is this baseline feature, which is very important. Something I just mentioned also is that NDepend is also gathering some information from your preferred code coverage tooling, like Encover, .cover, OpenCover, or even Visual Studio. So NDepend can gather all this data, and then you can mix it all. Like I want new method, so there is baseline. That is complex enough, so there is a metric on the method, and that is not covered by test. So that's very interesting. You can mix it all. And what is very interesting for all the developers is that the NDepend rules are actually C# query because the code model is very high level. All the metrics are provided out of the box, for example, and all the primitives to do baseline, etc. So in just a few lines of code, you can write in your Visual Studio a query and immediately see the results on your code base. And so of course there are like 200 default rules, but what's interesting is that it's very easy to customize the rules and write your own rule. So I wanted to talk about that because that makes a big change with what people are often using with Roslyn Analyzer or ReSharper or whatever. That NDepend is more complementary because more complementary to this major tool. And actually, that's a good thing for us because we don't want to be competitor with Roslyn or ReSharper. They are very, very big guys. And actually, we are using their tool also on the NDepend development. So yeah, some other interesting things is that you can ask for regression, for example, like which type was complex, for example, or complex enough and became even more complex, for example. Another thing very interesting is that you can do some API breaking changes. Okay, you can. There are some default rules that are only restraining themselves on the public API and that are looking at the changes. And for example, if you have an interface that you are adding some members to the interface, this can be a breaking change for your clients. Okay, and so NDepend can have this kind of warning. Okay,
That's you made a good point when bringing up when implementing static code analysis with existing code bases. There's going to be lots of warnings, lots of problems that any tool would come up with, and so that's an important point, just to be able to create a baseline and say going forward the changes are going to be better than maybe they have been in the past, because the old adage that I've heard so many times is, if it's not tested, it's broken. And with static code analysis, if we're not checking that we have complex code types that are too big, then guaranteed there's going to be problems in the code base, where if we inspected every line of code, we could find it, but this tool just helps us find them somewhat more quickly. But with any tool, whether it's NDepend or another static analysis tool, how does someone go about, how should they think about this realm of static analysis and making the decisions of what rules are important to them? Because you have every rule under the sun enabled, and it gives you tons of warnings, but what advice would you give to someone and how to even think about what things to catch? Because there's so many rules that are available.
Yeah, there are many rules. There are rules about security, rules about design, about like solid, for example, solid design, like I say, about like regression, etc. Really, only an empirical, I hope I say it well, empirical approach can work. Of course, first you try the tool or range of tools to see which one fits you best, and then you discuss with the team, like, hey, do you really consider that? For example, NDepend has this rule, like, it doesn't like if a class is not sealed. Okay, and that's very my rule, because I don't like unsealed class, because for me a class to be derivable, it requires a lot of work. It's not easy to make to make a class that will be reused easily through derivation. It's not easy at all. And there are large books written just on that topic. So for me, all class should be sealed by default. Okay, and NDepend this rule will just check if your class is public. Maybe it's too late, or of course you can change the rule. But maybe you already have tons of clients deriving from this class, even though it was not intended to be subclassed. Okay, but then if the classes is internal to your code, then it's easy to check if some other class are deriving for it or not. But if it's not, then NDepend can for sure say, hey, seal me this class, because in the future, if someone start to write subclass and it's not designed in for, it will be very a big problem to maintain. So this is my very own opinion. And I had a chance to talk with many other seasoned software developers about, for example, this very specific rule that I just gave an example. And not everybody agreed, especially the one that designed C#. They didn't put the unseal keyword to make sure that they wanted they wanted every classes people write by default. They wanted it to be open for subclassing.
Right.
Okay. So on this opinion, there is no, on this particular point, and on most of the points actually in software design, we can have a lot of discussion, and maybe at the end of the day, we will not agree. So really, it's really what I wanted to say is that it's really a test of everybody, and every kind of rules, or at least the rule sets, like I described it earlier, must be discussed with the team. Do we, for example, do we really want all classes written from now to be 100% covered by test? or maybe if 90% by test. But if it's 90% by test, does the 10% remaining contain all the bug-prone code or not?
Right.
Do we really want that? Or you see, so this is really, there is a lot of talk in what's interesting is that really code writing is really an art. We cannot say it otherwise, and everybody has an opinion to that. And the same way you want to apply a rule like on the C class, for example, see me or your class. The same way for any rules you want to discuss with your team, and should we abide by that or by this kind of standard or not? And of course, at the end of the day, no matter which tool you are using, you can disable the rule or enable it, or maybe tweak it. But one good point with NDepend is the rules are very easy to tweak because it's just C# query that you edit in Visual Studio that are run directly. So that's one strong point of the tool, to be very, very easily tweakable.
Well, that's a good point. And especially in the world where you are shipping a NuGet package or shipping an SDK or a library, that's going to be one environment, and you might have a different rule set for code that lives in that environment, separate from code that is one small internal application. And applications are getting smaller and smaller these days with the popularity of microservices, of just breaking up systems into smaller and smaller code bases. Perhaps it's a different set of rules for that type of code that you're not going to ship as a part of a library to anyone else. It's just code for that application, being very different from code that's part of a library that's going to be widely distributed.
Yeah. After all this code quality and design things, like the community is talking about from like 3 decades by now, they all come from the idea that quick and dirty is bad. But frankly, how many startups get started with quick and dirty code and are now making millions and millions of dollars?
Right.
Certainly many. So quick and dirty can make sense in some situation, and at that point you want to lower down your level of code quality. But I just said that. But in the real world, it's more about like you have a lot of junior in your team, and you don't want them to say, hey, we need to do quick and dirty, and then we're gonna disable all the rules.
Right.
That situation certainly you don't want. So you have to certainly need a certain expertise and software to be able to say, hey, now we're gonna have this prototype because we quickly need to see if there is a market for that, for example, and then okay, let's go. But so in some situation it's possible. But most of the time, in my opinion, quick and dirty is not the right way.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
So when it comes to when it comes to finding these problems, you mentioned interfaces that have too many members that are too big. You mentioned code that looks to be too complex. How would you define, or how do you go about determining, that is too complex? I mean, if we look at it with our eyeballs and we're just scrolling and scrolling and scrolling, and there's a massive amount of code, tons of if statements, we can all say, oh gosh, it's going to take me a long time to understand what that code is doing. But treating it as data, how do you determine that this code here is complex? So
this is a very interesting question, because there are several ways to go. So the first way is to go with well-known code metrics. Okay, so some well-known code metric, for example, it includes like cyclomatic complexity, okay, which is a very well-known metric. So basically, this number is the number of execution passed in a method, okay, and to infer this number, you just count very easily the number if, the number of else, the number of A, or or in your method. Maybe you can count the number of switch and case, or maybe not, because these are not necessarily a problem. Okay, so cyclomatic complexity is certainly the most adopted quality metrics, because if a method have like tons of if and else, it will be very hard to understand and to maintain and to test. Okay, so certainly such method must be rewritten in many smaller methods, or even a whole framework with several classes. These things happens. Then you have some more metrics, like one I think immediately is code coverage. Okay, since NDepend can import code coverage and reconciliate the code coverage with all your other tools. So as I said before, one interesting thing is to write code queries to both check which methods are both complex, okay, in the sense I just described, and are not covered by tests. Okay, because typically if you have a complexity of 10, which means you have 10 execution paths, ideally you really want 10 tests to go all through all this path. Okay, so this is a complex method. That's typically that's the rule, and I mean that's the idea.
Well, that's interesting. Does it correlate and say, if I have a cyclomatic complexity of 10, but I have less than 10 tests, show me a warning?
NDepend doesn't do this particular, because personally I really believe in the coverage. But yes, that is possible. Yeah. Actually, yes. If your NDepend is analyzing also the test code, which is not necessarily recommended, but if you treat the test code also as data, the same way you treat your application data, then you can certainly write a rule. That's maybe a rule to have per default disable.
Okay.
But definitely the idea. But if for example you have one giant test that is 100% covering the method, it's certainly worse than having like 10 tests covering fully your giant method. So, but yeah, this is definitely something that can be queried from the code base, as long as the test is in the code.
Gotcha.
Some other interesting metric is about cohesion. So one famous
cohesion
of classes. One is named LCOP, lack of cohesion of method for a class. So the idea is that if you have all methods of your class are using all the instance field of your class, the class is considered utterly cohesive. Okay, because I think this is easy to understand. And cohesive is a very important idea in software quality, because you have this solid principle, which is SRP, single responsibility principle. Actually, I just wrote a lot about it recently on the NDepend blog post, and the NDepend blog. And the idea of big classes is that they have tons of responsibility. They are responsibility for like persistence and user interface, and you have a lot of business logic also in the class. So the name here is also God class. Often we call such class God class. Does do too much. And what's interesting with SRP is that it's really related to the code as an art. Okay, it's an art to write code, and following properly the SRP, the single responsibility principle, it's hard, and interestingly enough, it cannot be really measured by a tool. Okay, but what's interesting is that with approach like this metric LCOM, just about cohesive class, and also you can analyze, for example, the number of namespaces consumed by a class. For example, if the class is consuming system.xml and maybe WPF namespaces, and maybe it tries to do too much if it tries to do some XML and some UI, for example. So you can try to do some query, and even though you won't be able to say it's perfect SRP, at least you will be able to say it's not SRP. You see, this class doesn't satisfy.
Right.
It's too complex because it's not cohesive, because it's using too much, it's doing too much, and because its size is too big. Okay.
That's interesting. If all methods of a class are using all of the instance fields, then the class is considered to be completely cohesive and will have the best score. But if one of the methods doesn't use all of the instance fields, then that method would be a violation of cohesion.
Yeah, and from this ID, with the outcome, you can get a number, and from this number, then you can maybe infer some stuff. There are some caveats because, for example, if you consider some totally dry class, like for example, some DTO, like some data transfer object that
The
are
dry
pure
as in
really,
don't repeat yourself?
yeah, yes. No, not this. I mean, no, that's not the right word. If you only have a class with just properties,
Okay, right.
it won't be cohesive at all because the get and the set, which are considered a method, are just using their backing field, and it's still not cohesive. So for example, the rules that using the LCOM matrix also have to make sure with some other property, maybe the number of line of code or the complexity of the method, etc., that you are not referring to such a DTO class that just have properties getter and setter. Okay,
Yep.
so that's the key with static analysis is that you, especially with code metric, is that it's not exactly a yardstick to say good or not good, but you have to think a bit. And that's what's interesting with rule is that we can add up some logic in the rules to try to avoid something I didn't mention yet, which is the false positive. Okay, suppose you have a rule about cohesion, and then all your properties only classes are reported. Of course, everybody will have this. Hey, this is not. We don't mind. We don't want this rule to apply on such classes. So this is a big point. So the first big point of static analysis was about caring mostly on new code or refactor code recently. And the second big thing about static analysis is to avoid reporting false positive, like, hey, you have a problem, but actually, humanly, you don't have at all a problem. It's just the tool is just stupid. And this is something we and all the tools are working hard. On a weekly basis, we have a user reporting us some, hey, this is stupid, this one shouldn't be reported out. You're absolutely right. So every single version brings his own notes of less false positive. This is very, very, very important. And just to finish on code metrics, there is the mother of all code metrics, which is the technical debt. Okay.
Yes, technical debt.
So this is another big word. And what's interesting is that the tool like NDepend can put a number on the technical debt, and also the new technical debt added from the baseline. So this is the model of all metrics. This is a way to unify everything, all the rules, all the metrics, everything you want to all the kind of score you want to have in your code, because the technical debt is actually the effort to fix problems. So this is interesting because it will measure all for each problem, and NDepend has some formulas in the link query embedded, and these formula are here to produce from a problem, translate the problem into minutes. And the minutes is the number of minutes needed to fix the problem. So for example, for the rule about the sealed class, once you decide to have most of your class sealed, it will take you probably maybe 1 minute or 2 for each classes. So this one will be very easy. But on the other side, if you have a God class with tons of methods, very complex, not very well covered, etc., you can easily have many hours and maybe 1 day or maybe 2 days just for the particular class. So this is what is very interesting with technical debt is that we try to have some very fine-tuned estimation, very realistic estimation. And then this estimation, they are especially interesting for the developer, but they are even more interesting for the manager.
Yes. The manager wants to know, okay, we have problems. How long is it going to take to fix the problems?
Yeah, absolutely. So, and of course, you can transform this minute and this hour, or as we say, the man minute, or better say the human minutes, because we don't want to say man or woman minutes nowadays. But if you transform these human minutes into payroll, like I know I'm paying my developer that amount per hour, per man hour, then you can have a budget and then you want to go from the problems you have in code to the budget. And that can lead to some very interesting. So, for example, NDepend can measure things like if your code is not covered, taking account how complex it is, objectively from the code itself, you will need that amount of time to write some tests and maybe refactor, because when you write some text, you often want to refactor the code. So
Right.
it can provide you with this kind of metric. Another thing that actually I think NDepend did an innovation, because it's the only tool that does that. It's not only measuring the effort to fix, but it's also measuring the cost per year to not fix. So suppose you have a problem and you don't fix it.
That's true. That's an ongoing cost, interest on the technical debt.
Yeah, you're going to have a cost for that. And then what's even more interesting, you can put in balance these two metrics that we can call it, for example, the technical debt and the annual interest. Okay, because the debt metaphor
Right.
comes with interest. So we can call that this interest per year. And then from these two amounts, you can infer the breaking point. The point from now, like if you don't fix it from now, maybe in 1 year, the cost of the problem will be as big as the cost to fix the problem. Okay,
Got it.
So this can be used as a way to prioritize somehow. Of course, not everything is.
Right.
It's not mathematics, it's software, which is more hard. But this kind of metric can be very useful. This is another way to put a severity on your problems, on your issue. Okay, and actually, NDepend infer the severity of a problem from his annual interest value. Like if a problem takes like a week per year, a man week per year, if it's not fixed now, if it's a big architectural problem or whatever, or a test problem.
That's really what the team managers need to know. They need to know how to prioritize and need to know cost and budgets. And this topic is so massive. There's no way we could cover it all in just one show or multiple shows. But there's so much information here, and I think every listener should be putting into place some form of static code analysis into their DevOps environments. As the listeners kind of dig in and start researching, if they've never done static analysis, what resources would you point them to in order to learn more?
So it really depends on the tool set you're using. So you have tons of resourcing about Roslyn, about the existing rules, about the how to develop your own Roslyn analyzer. The same way on the NDepend website or on the ReSharper website, and all the other tools on the SonarCube website. You have tons of resources. Everybody wants to make sure that the rule they provide to the community are very very well explained and understandable, especially taking account what you just said at the beginning, like which rule set we want to apply. So we really need to understand why a rule is interesting or not. Okay, and maybe just to finish, another point very interesting in static analysis we didn't discuss is about build failure. Static analysis can be especially useful to fail the build upon some special condition, some special criteria. And typically these criteria are named quality gates. You're not going to fail the build because some classes are not sealed, but maybe you're going to fail the build because the new code introduced in the baseline is not well covered. Mm-hmm. Okay, so that's higher level than rules. There is these quality gates, and this is something very important because in DevOps we're very interested by failing the build at the right time for the right reason.
Yeah, good point. Wow, this is a lot of information. I really appreciate your time coming on board and talking about static code analysis, Patrick. I can hear the wheels spinning in our listeners' heads as they figure out how to get their DevOps environments hardened with some of these checks. So thanks so much for the time and thanks for being with me.
Thanks so much, Jeffrey, for the opportunity.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.